In this lecture, I'm going to explain about adsorption isotherm. Adsorption isotherm, it is actually a plot of amount of adsorbed material and the equilibrium pressure or the equilibrium concentration. If the adsorbate is in the solution, I'm just going to find out experimentally the amount of adsorbed material, at various pressure, or at various concentration. See, I just have a container. I just have a reaction bottle. For example, I have a reaction bottle. Here I have taken some charcoal. It's a charcoal powder. Charcoal powder is taken inside, and I have taken acetic acid. So this acetic acid will adsorb on the charcoal at various concentration. For example, point 0.1 or 0.2 and 0.3 and etc. At various concentrations, I'm going to find out the amount of acetic acid adsorbed on the charcoal. Amount of acetic acid adsorbed on the charcoal at various concentration. This is simple experiment I'm going to do. Or if it is in case of gaseous molecule, I'm just going to just a container. Inside there is a gas molecule, say for example nitrogen. I've taken mica, for example. Nitrogen will adsorb on the mica. I have to allow nitrogen to adsorb on the mica. That at various pressure I'm going to find out the amount of nitrogen adsorbed on the mica, and the amount maybe in the volume, or maybe in weight or in the volume, that is plotted in the y-axis. Pressure or concentration, pressure in terms of gases, concentration in terms of solution. If I plot, I will get a curve. And this curve is called adsorption isotherm. It's simply amount of adsorbed material and simply a plot of amount of adsorbed material and the pressure or concentration, equilibrium pressure or equilibrium concentration, is called adsorption isotherm. In general, it is observed there are five types of adsorption isotherm. The first type will appear, the curve for the first type of adsorption, the curve will look like this. The first type of adsorption, the curve looks like this. That is, you see here, when the inside this container, when you increase the pressure of nitrogen, see the adsorbed nitrogen on the adsorbent on the mica increases. See, this increase this is actually increasing, and it reaches a limiting value, and the curve is flattened. This shows me that this is considered, this is my adsorbent solid. When you increase the pressure, for example nitrogen, when you increase the pressure of nitrogen, equilibrium pressure of the nitrogen, the amount of nitrogen will increase, the amount of adsorbed nitrogen will increase. When after it is completed, I mean after the first it forms a first layer, then you see the amount of adsorbed material is actually limiting, it's no more increasing. So that means that this curve shows me that the formation of the only one layer, that is monolayer. This curve actually explains monolayer formation. This is not suitable example. I think this is not a suitable example for this curve. Maybe you can think that this is a gas that is adsorbing on a adsorbent, You see, this curve is actually explains the formation of monolayer. That's what this curve actually shows. When you increase the pressure, amount of adsorbed material increases, but after reaching certain pressure, the adsorbed material, it's not increasing. The amount of adsorbed material is flattened, it's not increasing. This means that it is involving only the formation of monolayer. It is not forming the multi-layer. This means monolayer formation is actually chemical adsorption. Chemical adsorption. So chemical adsorption gives any chemical adsorption gives you this type of adsorption isotherm. So chemical adsorption it will form only the monolayer. Chemical adsorption form only the monolayer. So for the chemical adsorption, the adsorption isotherm will appear like this. So this is actually adsorption isotherm. This is first type of curve. This is first type of curve. The same way you can see there are other types of curves. The second type of curves look like this. The pressure and the adsorbed amount of adsorbed material. The y-axis, if you plot, you will see this type of curve. You will see this type of curve. This is a second type. This is type 2. You know what happens is, when you increase the pressure, amount of adsorbed material increases, and then you see some limiting value attains. Then further increasing the pressure of the adsorbate, you see further amount of adsorbed material is actually increasing. This shows multi-layer formation. Multi-layer adsorption is actually forming. That is why you get this type of curve. You have a solid surface. The first layer up to this, when you increase the pressure up to this point, the absorbed material occupies the first layer. The material occupies completely occupying the first layer, and further increasing the pressure actually involves the another layer to be formed, a second layer to be formed. So further increasing the pressure, the adsorbed material, amount of adsorbed material actually increases. This is due to multi-layer formation. This is type 2 curve. This is how the type 2 curve actually looks like this. And let me the another type of curve is the pressure is amount of adsorbed material in the y-axis. If you plot, you will also get this type of curves. This is type 3 curves. Type 3 curves. And this is also involves the multi-layer formation. All the 5 types of curves that I'm going to draw here. This is type 3, and this is type 4. This is type 4, amount of adsorbed material and the pressure on the x-axis. So this is 4th type of curve. This is 5th type of curve. So amount of adsorbed material in the y-axis and pressure in the x-axis. This is 5th curve. This is type 5, 5th curve. You notice here, except first, all other four types of adsorption isotherm involves formation of multi-layer adsorption. Because you see this is multi-layer. This is also multi-layer. When you increase the pressure, you see amount of absorption actually increases. Keep on increasing. When you increase, the amount of adsorbed material increases. That means that's supposed to form a multi-layer. If it is not forming multi-layer, then it must reach a limiting value. but it is not reaching a limiting value. Here also you see it's keep on increasing, right? It keep on increasing, and here also it is increasing, here also it is increasing. So for all the four types of type 2 to type 5, they are actually forming multi-layer, but type 1 is forming monolayer. Monolayer. So therefore this is chemisorption. This curve is for chemisorption, chemical adsorption, and this four types of curves is for physical adsorption. And all these experimentally observed curves have been supported by the theoretical explanations. One of the explanations was given by Freundlich. He based on his experiment, he actually proposed an empirical formula which actually in this form. It is actually, see, Freundlich isotherm. He just proposed an equation, y equal to k p power 1 by n. P is called the equilibrium pressure if it is gaseous molecules involves, and you can also replace pressure with concentration for the solutions. Y is called the amount of weight or volume of gas adsorbed. Maybe for unit mass of adsorbent, that is, or simply you can write y equal to x by m. M is called the mass of adsorbent and x is called the weight of the mass of the amount of adsorbed material. This is the amount of adsorbent solid. This is the amount of solid, mass of solid, and this is amount of adsorbed material. This is the equation he proposed. This is empirical equation. It is based on this experiment. He just related some of the related properties. He is actually proposed this equation, and to check its validity, I'm just taking log and making them into a straight line. Log k. This is now in the straight line equation, in the form of straight line equation. If I plot logarithm y, that is, y is called the amount of adsorbed material per unit mass of adsorbent, and the log p in the x-axis. If I plot, I must get a straight line, but I actually get straight line at low pressure. I actually get a straight line with in low pressure, but when the pressure is increased at a high pressure, this straight line actually deviates. The points will form a straight line only at low pressure, but it has actually deviates from the high when the pressure is high. So therefore this Freundlich isotherm is applicable only to the low pressure. So it is not providing a good acceptable. This is not acceptable because it is applicable only to the low pressure, but it is not applicable to when the pressure is increased. So this equation is applicable only for the low pressure, and this is not actually reproducing the experimental data. So it is not providing a satisfactory result. Okay, that's about Freundlich adsorption isotherm. So So I just explained in this lecture, in this video lecture, about what is adsorption isotherm, and then I said there are 5 types of adsorption curves. But the first type of curve is for chemical adsorption, because it explains the formation of monolayer. But all other types, all other 2 to 4, they actually involves in the multi-layer formation, multi-layer adsorption, and therefore they and this 4 curves for this is actually for the physical adsorption. Physical adsorptions only will form a multi-layer. A chemical adsorption actually forms only the monolayer, because the solid, this is your solid surface adsorbent, and they will form a chemical bond with the adsorbate. So it therefore, since it is forming a chemical bond, it will allow only the first layer. The second layer of molecule will not form chemical bond with the molecule, with the adsorbent. So therefore the chemisorption is for mono. The chemisorption actually allows only the possibility is actually only one layer, monolayer, not the multi-layer. But the physical adsorption, it's simply van der Waals force actually involves. So if there is a chance of forming multi-layer in case of physical adsorption. So this is about Freundlich isotherm, adsorption isotherm. Next, I must explain about Langmuir adsorption isotherm. Langmuir adsorption isotherm. I'll do it in next video.